Right, well, correlation is an important concept in data analysis. So here I want to give you some idea of the intuitive meaning of correlation. Now, there is a mathematical definition. Suppose you have two sequences of numbers. You should think of these two sequences as two features or two dimensions. We can plot this on an axis where the x would be on the x-axis and the y would be on the y-axis. Right, so the x dot y would be a series of points in this plane. Right, something like this. Okay, where the x is the x-coordinate, y is the y-coordinate. Now, what does this xj minus x dot mean? X bar mean? X bar is the mean value. So the mean value x bar, y bar would be in the center of this cloud of points. So x bar, y bar might be located here. So x minus x bar is the deviation of x from this mean point. And yj minus y bar would be the y deviation from points from these points. For instance, this point here that I'm pointing to, the deviation would be the vertical distance between this blue point and the light blue point that's the center. Right? Now, one way to deal with this situation is simply to move your coordinate axes so it's centered at the center of the data. Then it's easier to picture. So I could just move my coordinate axes so that they pass through the center of the data. Okay? Then xj minus x bar is simply the x-coordinate in this new axis. Right? This value, the value of x relative to the green axis, is in fact xj minus x bar. Right? So I've got these points. I have their x-coordinates. Those are the xj minus x bars. The y-coordinates are the yj minus y bars. Now, you may recognize down here, this is called the variance. So this is how the x-coordinates vary, and this is how the y-coordinates vary. And we're taking the square root of the product. So what you can do to see what this is saying is you can rescale. So basically the x varies from -1 to 1, and y varies from -1 to 1. So let me see if I can do that. Let's take a case where let's suppose that we've already moved our axes here. I'll have to see if I can do this. And let's take a cloud of points. We'll just move them around here somehow. Okay. I try to make it so the data is already centered. And as I said, we've moved the green axis to be at the center of the x and y data. Okay, so we have something like this. Now you can see the x varies more than the y. So as I said, let me see if I can do this. So I'm going to take these axes here, and I'm going to copy this. Whoops, didn't do it. Let me try again. Okay. There we go. All right. Now, what I'm going to do is I'm going to stretch this picture so the x and the y vary about the same. Right? The x is varying more than the y. Let me stretch it out this way so the x and the y vary about the same. Okay. All right. Now, if you have the x and y vary about the same, you can see that this data is fairly diagonal. Okay. Not exactly diagonal, but it's lining up pretty close on the diagonal line. So correlation measures the degree of diagonality. Okay, so this is a fairly large positive correlation. Okay, so I can say that. I can say that correlation measures the degree of diagonality of the data. And you could have a positive or negative. Okay. All right, now let me show you another example here. Suppose I take my axes. So again, I'm going to take my data and I'm basically going to draw my axes through the center of the data. All right. Let's take a case where we have data like this. Most of it is something like this. Well, let's do it this way because I drew my axes long. Okay, so I'm going to do something like this. I shouldn't have started out so far. Let's make it easier for myself. I'm going to do it this way. Unfortunately, it's not passing directly through the center. It's okay. This is going to be a little bit distorted, but we'll see how we can make this work. All right. Now, this doesn't look too diagonal. It looks like it's mostly lining up along the x-axis. I think my x is a little bit too long. Let me erase part of it. All right. So here's my data. But what I'm going to do is I'm going to rescale so the x and y total variation is about the same. Okay. So this is original data. Here's the original data. And like I said, it looks like it's mostly lined up along the x-axis. But I'm going to rescale it so the x and y variation is the same. So I'm going to select this. So a point I want to make is that correlation actually has nothing to do with how spread out the data is. Right. This data seems very spread out along the x-axis, but correlation has nothing to do with that, because correlation is preserved, as I said, it's preserved under rescaling. So let's do that again. And here I'm going to stretch out the y so the x and y variation is about the same. All right. So you can see that the data is still quite diagonal. Okay. So this is going to have a positive correlation that is close to 1. 1 is a large correlation. Okay. All right, so this is the rescale data. Okay. Right. And when you notice when I rescaled it, I just stretched the axes. Stretching the axis amounts to multiplying the y-coordinate by some constant. And that's what you call rescaling. It's basically putting different tick marks on your axis. Okay. And then look at the degree of diagonality. Okay. Well, let's do an example where you don't have a strong correlation. Okay. Here, if I have some axes like this, here's my axes. Let me make a cloud of points. Something like, well, I'll do it in pink. Well, that's not good. Let's go back to, well, let's just do this. This is a good size. All right, so here, let me make another cloud of points here. All right, let's do it this way. All right. Now here you see that the data is fairly elongated. It seems that there's more x than y, but that really doesn't matter, because as I said, I'm going to rescale the data so that the x and y variation is about the same. So let me cut off my axes because I don't need so much over here. Whoops, that's not what I want. I want the big eraser. Okay, I'll cut off my axes here. So here's another example. Okay, and let me rescale so that the x and y variation is about the same. And look at the degree of diagonality. Okay, so let me take this picture, and I'll go and select it, and I'll make it bigger down here. This means, again, I'm going to stretch out the y so that the x and y variation is about the same. You can see it's distorting the points. So you can see that in this case, from here to here is about the same as from here to here. So there's a little bit of diagonal trend here. You can see that the data is poking out more in the first and third quadrant more than it does in the second and fourth quadrant. So there's a little bit of diagonality, but not a lot. So this is weak positive correlation. So if you want to evaluate the correlation, then in your mind, this is what you should do. Stretch out the data so that the x and y variation is about the same. And how much does it lie along the 45-degree line? Now, of course, if I flip this around, I could actually do this, I think. If I had a case where let me see if I can do this. No, it won't let me flip it around. Actually, it probably will let me rotate. I think that there was something about this that I could rotate. Whoops. I'll rotate. Okay, here we go. And I'll rotate right by 90 degrees. Okay. Now, what happened there? Okay, let's try again. How about I just flip horizontal? All right, good. Now you can see here, if I had a case like this, this is a weak negative correlation, right? Because if I did stretch it out, there would be diagonality, but it would be diagonally in the other direction. So this is going to be weak negative diagonality, or weak negative correlation. Okay, so hopefully that gives you some intuitive idea about what correlation means.